Pancreas is an organ that has two separate functions dictated by two very separate populations of cells that exist in this one organ. The bulk of your pancreatic cells are exocrine cells that secrete digestive enzymes into the small intestine. These cells function as part of the digestive system. But the pancreas also has populations of cells that release hormones such as insulin. And these cell populations have an endocrine function because these cells release their hormones into blood circulation. Your pancreas is tucked between your small intestine and stomach. It's referred to as a retroperitoneal organ because it's not fully contained within the peritoneal cavity. Uh, the, I, the tail of it kind of peeks out. The pancreas is vascularized like any other organ and can therefore secrete its hormones directly into circulation instead of into the small intestine as its enzymes are secreted. The ductwork that you see here on this pancreas, it collects the digestive enzymes and spews them into the small intestine, a process that we talk more about in the digestive system lectures. This section here of the pancreas is referred to as the head. Let me circle that. This is the head. And this section here is referred to as the tail. All of these little bubbles are referred to as lobes. When we zoom in on the pancreas with the microscope, we're very easily able to see that the acinar cells that generate all of those digestive enzymes form a bulk of the pancreas. However, there are cells that have endocrine function, and they're isolated to what were referred to as pancreatic islets, which are like little islands of more lightly stained cells within the acinar cells. These pancreatic islets look like scattered splotches within the pancreas. And within the pancreatic islets are various populations of cells that secrete hormones. The two most important to us are alpha cells that create or secrete glucagon and beta cells that secrete insulin and amylin. The effects of insulin are covered in the next slide, as well as glucagon. Amylin, in general, it works to reduce spikes. So it works on moderating transitions in blood glucose from like a hunger state to a fed state. In general, alpha cells are found toward the inside of a pancreatic islet, and beta cells are usually found toward the outside. Alpha cells stain with a bright pink nucleus, and beta cells stain with more of a purple colored cytoplasm. In addition to alpha and beta cells, there are other cells. One such population is called D cells. D cells they're difficult to differentiate without more specialty stains. They look a lot like alpha cells. But D cells secrete somatostatin, which acts as a local regulator for alpha and beta cells. So the triggers for alpha and beta cells are certainly humoral by monitoring the blood, but it's not so simple. There are other local cell populations that really regulate alpha and beta cells. So there's more than one input on whether alpha and beta cells are supposed to be secreting their hormone or supposed to be holding back their hormone. Insulin and glucagon regulate blood glucose levels. When blood glucose rises, like after breakfast, the alpha cells secrete insulin. And when blood glucose drops, like when you get hangry before lunch, the beta cells secrete glucagon to raise it. So remember that neither of these hormones makes a change for blood glucose, right? They're just chemical messengers. But both of these hormones are signals to organs that are effectors and tissues that are effectors that can adjust the blood glucose levels. Remember, an effector and its effect need to be differentiated when thinking about the effects of hormone. And what I mean is like saying sweating as opposed to saying sweat glands, right? We need an effector and an effect. Okay, so insulin increases the permeability of all of your cells to glucose, and that enables them to uptake the glucose, lowering your blood glucose levels. The liver is able to uptake glucose and turn it into glycogen, kind of like linking it together, and thus that can also lower blood glucose. We can also start to make fat deposits as well, lowering blood glucose. Okay, so glucagon, you would think that it does exactly the opposite, but not really. It does the opposite with the liver. It allows the liver to, here we go, it allows the liver to take the glycogen that was maybe made after breakfast and break it down, releasing the glucose and raising blood glucose levels. We can also, since you need energy, we can also resort to adipose breakdown and use those fatty acids for energy as well. So, glucagon and insulin are antagonistic hormones. They have the opposite effects, right? And just like the calcium hormones, one of them raises the level of its marker in blood, and the other one lowers the level of its marker in blood. Diabetes can occur when the body fails to produce insulin effectively, or when cells start to become insulin resistant. In advanced stages like diabetes mellitus, symptoms include extreme thirst, like all of the time, which is called polydipsia, excessive urination, again, like all of the time, called polyuria, and extreme hunger, polyphagia, right? You're always hungry because your cells are not taking up insulin. These symptoms, they arise because the body just can't get glucose into cells. And this leads to a saying that people with diabetes with mellitus, people with diabetes mellitus are starving in the land of plenty, despite abundant food and water intake.